Hello everyone. Today we'll be discussing about encapsulating security payload format. And my name is K. Samarth N. Kamath. My USN is 4SF18CS055 and I'm from 7th C. So, what is this ESP? It is an encryption algorithm. So, encryption algorithm basically encrypts the data that needs to be sent in a channel. So, security association. Let us understand a bit deeper into the ESP format. So, before we get into ESP format, let us understand what are the IP securities that are associated with this. So, if we go for a security association, whenever we need to send something to a server from a client needs to have a security association with the server. That means to say that it needs to have a key that can help client to connect with the server. So let us understand what is there in the security association of a client. Parameters to identify a security association. So security association will contain security parameter index. This parameter index is used for uniquely identifying the security association. And then comes the IP destination address. This is the address of the destination node that will be receiving the data node. And then comes the protocol identifier. This is for identification of the protocol that is being used in the transfer of the data. So now, all the previous security associations that we have discussed are all going to be stored in a security association database. This database will be the main source to identify each of the security associations. So now already we have discussed that the parameters will be stored in a database called a security parameter database. So now let us understand the parameters that will be stored in the database. First parameter is security parameter index. So this is the index that we have already discussed about, which uniquely identifies the security parameter. And then comes the sequence number counter. So sequence number counter is the counter that will count the number of security parameters that have been created, and it will also count the sequence in which the security parameters are created. And then comes the sequence number overflow. This will indicate the overflow of the sequence numbers if it is out of the bound of the database. And then comes the anti-replay window. Anti-replay window helps to understand if there is a repeating data that is coming from the sender. Then comes the authentication header information. This is the authentication header. um, the authentication header is actually a protocol like ESP, which will be discussed in the other module. And then comes the ESP information. ESP information is the information that is uh, associated with the ESP. Then comes the IP security protocol mode. There are different modes, namely the transport protocol mode and then tunnel protocol mode, which will be discussed later. And then comes the lifetime of SA, that is security. So security association. So lifetime of security association is the time span that the security association is valid for. Now that we know the background story about the ESP format, now let's come to the main story behind it. The diagram that we see in front of us is the main diagram of the ESP format. Now let us go one by one. The first one is a security parameter index. The security parameter index is of 32 bits length, and it identifies a security association. The second one is sequence number, which is again of 32 bits length. It is a monotonically increasing counter value which provides an anti replay function as in the case of authentication header. The next one is payload data, which is of variable length. This is a transport level segment in transport mode or IP packet internal mode that is protected by encryption. Next comes the padding, which is of 0 to 255 bytes. This padding actually accounts to the uh, encryption algorithm. If we use an encryption algorithm which uses die and die values or uh, uh, 2 bytes together, then we will use a padding to indicate a duplicating value. If we are using other encryption functions, then the padding can be used to fill the empty spaces in the target size of the payload. Then comes the pad length. The pad length is of 8 bits. This indicates the number of pad bytes immediately preceding this field. Next comes next header, which is again 8 bits of length. This indicates the type of data contained in the payload data field by identifying the first header in that payload. Example, an extension header in IPv6 or an upper layer protocol such as TCP. Integrity check value. Integrity check value is of variable length, and that it contains the integrity check value computed over the ESP packet minus the authentication data field. When any combined mode algorithm is employed, the algorithm itself expected to return both decrypted plain text and pass or fail indication for the integrity check. For combined mode algorithms, the ICV, that is the integrated check value that would normally appear at the end of the ESP packet, can be omitted. When the ICV is omitted and integrity is selected, it is the responsibility of the combined mode algorithm to encode within the payload data an ICV equivalent means of verifying the integrity of the packet. Let us see in the next one. So in the previous slide, we have seen the top level format of an ESP packet. Now we will see the substructure of payload data. So before we have seen that there was a payload over here and there was no initialization value IV and TFC padding, which is now added as an substructure of the payload. Two additional fields are added. One is an initialization value IV or nouns. If present, this is required by the encryption or authenticated encryption algorithm used for ESP. If tunnel mode is being used, then the IP security implementation may add the TFC padding, which is an optional and variable field. TFC traffic flow confidentiality padding is added after the payload data and before the padding field, as explained subsequently. It will be explained later. So this is all about this ESP format. Thank you for your patient listening.